Hey guys, this is Tejas Srinivas and today we are going to solve the math video homework question 3. So let's solve it. We are given with the equation of the shape of the hill that is represented by z is equal to this equation, and we are standing at a point P x comma y comma z and its coordinates are 60 comma 40 comma 966, and in the first bit it asks if we walk due south, will we start to ascend or descend and at what rate. So let me just represent a vector of us going down south. So that vector would be x bar is equal to 0 I cap minus j cap, and now to find the unit vector along south, we can say that x bar by mod of x, we get 0 I cap minus j cap 0 plus 1, so we get the same 0 I cap minus j cap. So now in order to find the ascending descending part, we got to find the directional derivative of the function z at point P along this vector. So since we are moving down the south, we can assume that the gradient of z would be delta z is equal to minus 0.01 x comma minus 0.02 y from this equation, and if we substitute the x as 60 and y as 40, we'd get 0.01 into 60 comma minus 0.02 into 40, we'd get minus 0.6 comma minus 0.8. So now in order to find the directional derivative, we have the formula duz is equal to gradient of z into the unit vector. So that would give us minus 0.6 comma minus 0.8 into 0 comma minus 1. So that would give us it is represented by dot product. It is given by dot product, I mean. So minus 0, this gives 0, and we would get the rate as 0.8. So since duz is greater than 0, we will ascend at a rate of 0.8. so that's the first bit, and moving on to the second bit, you start walking towards the northwest direction, which is like this. We can assume a vector in this direction. The vector would be x bar is equal to minus I cap plus j cap. The unit vector of this vector would be u bar is equal to x bar by x mod of x bar. So that would be minus I cap plus j cap by 1 plus 1 under root. So we'd get minus 1 by root 2 I cap plus 1 by root 2 j cap, and now gradient of z, the equation z would be delta z is equal to minus 0.01 x comma minus 0.02 y. So x and y were 60 and 40, if you would recall. So that would be minus 0.01 into 60 comma minus 0.02 into 40. So that would give us minus 0.6 comma minus 0.8. And now to find the directional derivative, we have the formula du into z. Duz is equal to gradient of z into unit vector u. So that would give us minus 0.6 comma minus 0.8, into, if you ignore I cap and j cap, minus 1 by root 2 plus 1 by root 2, sorry, comma 1 by root 2. So as is a dot product, the I cap coefficients will multiply each other. We get 0.6 into 1 by root 2 minus 0.8 into 1 by root 2. So we get minus 0.2 by root 2. So that would be minus 2 by 10 root 2, which we would get minus root 2 by 10. So that would give the, as in duz, as duz is less than 0, we will descend at this rate, at minus root 2 by 10. So moving on to the say bit, the direction of the slope would be largest in the direction of the gradient z. Let me just write it down. So we know from earlier that gradient of z is equal to minus 0.6 comma minus 0.8. Now as we are moving in the same direction of gradient z, our unit vector would also be minus 0.6 I cap plus minus 0.8 j cap by 0.36 plus 0.64 under root. So this would give us minus 0.6 I cap minus 0.8 j cap. Yeah, so moving forward, now to find the directional derivative, the formula would be, as we know earlier, gradient of z into the unit vector. So this would give us minus 0.6 minus 0.8 minus 0.6 comma minus 0.8. So dot product between these two would give us 0.36 plus 0.64. So this would give us 9. So the rate is 1. So that tells us that since duz is greater than 0, we ascend uphill, if you prefer, with the rate of 1. Now for finding the slope, we know a basic formula: tan theta is equal to dy by dx, where dy by dx is the rate of change of y with respect to x. Similarly, when comparing with the directional derivative, it is simply the rate of change of partial derivatives of x and y with respect to the change in directions of x and y, right? So we got the rate as 1, if you recall. So tan theta would be equal to 1. Then theta would be equal to 45 degrees. So now the rate of ascent would be 1, and the angle would be 45 degrees. So guys, I would like to add an important note. The units of rate for all the three cases would be, for all three cases that we solved, would be vertical meters by horizontal meters. I forgot to mention the rate unit at first. So yeah, that's it guys. Thank you for watching.